Hello, everybody, and welcome to another edition of our Tolly on Technology podcast. Very interesting topic today, as you can see, 800G and AI fabric testing. And we're very happy to have as our guest and our presenter, Aniket Khosla, who is the VP of Wireline Product Management for Spirent. Aniket, welcome.
Hi, Kevin. Thank you for having me. What I'll do today is quickly go through, four quick points around, the items that we'll be discussing today. At a high level, we'll start with, what trends, us as Spirent we're seeing, in the market right now, and what some of the challenges are associated with essentially being able to validate and test this growing and, burgeoning HSC and specifically AI market as well, and then kind of go through what benefits us, us as Spirent see in being able to actually test these things. All right?
Sounds good. I'll jump if I have any questions. Great.
All right. Thanks, Kevin. All right. So Ethernet's been around a really, really long time. As someone who's been a part of, this specific test and measurement industry, I have seen the rapid growth of 1 gig driving all the way up to now 1.6 terabit in many instances. But what's driving this rapid speed of, high-speed Ethernet, going specifically now to 800 gig and even 1.6 terabit, it's really the big cloud providers, the hyperscalers who are at the bleeding edge of this technological innovation. They're really, really pushing the boundaries of these higher speeds, going from 400 to 800, 800 to 1.6. But interestingly enough, some of the lower speeds like 1 gig, 2.5, 5 gig are finding new applications, right? You're seeing these speeds now being adopted in, industries like automotive, industrial automation. So, my headline here really is, Ethernet's ubiquitous. It's being used pretty much from, industrial applications, which are using the lower speeds, all the way up to the cloud providers and the hyperscalers who are really, really pushing the boundaries of these high performance speeds, going up all the way up to 1.6 terabit. Yeah. But the question remains, what's really driving these massive increases in speed? There's been a lot of chatter and talk. I'm sure a lot of you on this podcast have already heard about AI. That is probably one of the single largest drivers in the high-speed Ethernet world with the hyperscalers that is driving the higher speeds. Okay. The size of these AI workloads are so enormous that they, in an Ethernet-based network, demand a lot of bandwidth, right? So they're really, really pushing the hyperscalers fast to adopt these technologies. If you look at the graph on the right, we're still pretty much, in the age of about 400 gig at the hyperscalers. But if you look at what's estimated in 2024 and beyond, you can see how quickly between 2024 and 2025, 800 gig is expected to be adopted in these AI clusters, these back-end AI Ethernet-based clusters, with 1.6 not too far behind. So, the adoption cycles of these higher speeds going from 100 to 200, 200 to 400 and so on is getting shorter and shorter in every single tech turn. And we're expecting that to continue as well. Go ahead, Kevin.
Clearly at the very high end, we're going to have this. Do you have any idea of how this impacts the enterprise? How quickly the enterprise will move into these higher speeds?
So enterprise, Kevin, is a very broad term, right? If you talk about large enterprise, massive financial enterprise like banks and so on and so forth, we don't expect them to move up to 800 gig that quickly. 400 gig for sure, absolutely. There's no question there. But if you look at a typical evolution cycle in terms of, speed being adopted, we have seen, at least in North America, right? It's very different regionally. In North America, it's the hyperscalers that really jump onto the highest speeds first, followed by maybe 2 or 3 years later, the service providers, and then the enterprise customers. Now, obviously, if you're a significantly large enterprise customer who's running their own data center and has some form of an AI strategy where they want to offer their own AI services, yeah, there is a possibility they will adopt quicker. But we typically see enterprise at least 5 years behind the hyperscalers. So 400 gig now, 800 gig probably in another 4 or 5 years.
Thank you.
The question is why test 800 gig? We'll talk about 800 gig in particular, but I think it's important to also have some sort of industry context here. If you look back at the 100 gig market, right? I don't know how long it's been now, maybe 7, 8, 9 years ago. It was dominated by one or two vendors on the switch silicon side and on the switch vendor side, right? So in those specific instances, there was very little, real interoperability tests needed because the market was dominated so much by one or two different vendors. That changed with 400 gig and with 800 gig. There are a lot more players in the switch silicon system, in the switch ecosystem for 400 gig and 800 gig. And when you have, so many different players kind of competing for the same piece of the pie, people often have a significant need to get to market quickly, right? Every vendor wants to outdo the other vendor. Sure. So if you have a need to get to market first, you're going to really want to need to test to make sure that A, you're up to standard, B, you've done interoperability, you're validating your interpretation of what the spec looks like for 800 gig as an example. So if you look at a typical ecosystem, and this goes back, Kevin, to the slide that I, we talked about in the previous slide. If you look at the way we typically see, our customers, in how, their purchasing cycles go, our first customers are always the chipset vendors, right? They are the big switch silicon vendors who, are building switch ASICs or switch silicon, for these newer and higher speeds. So they will come on and test first, very, very early in their development cycles. That is typically followed by the cable and transceiver vendors, even though we see that change a little bit, more in the recent years. But once the chipset vendors are ready, we see the equipment manufacturers come on who are building their switches, routers, based on these chipsets, followed by the providers, followed by the hyperscalers, really. So, it's important to test to make sure you interoperate, you have the performance metrics you need to showcase and highlight why you're better than the rest, in a crowded ecosystem. So given that there's such a myriad of players now in, the 800 gig space, testing becomes even more important now to set yourself apart and stand out in the pack.
Right. And sure. And you got to start at the bottom of the stack, right? You got to start at the physical layer and work your way up. So it makes perfect sense.
Yeah, no, absolutely. Right. And, we deal pretty much with most of the major chipset vendors out there right now. So, getting in early with these chipset vendors, sets us up well to go and approach the equipment manufacturers or the hyperscalers that are using these chipsets in the switches and routers that they're using and that they're building. So, starting at the ground floor is incredibly important.
Yep. Very good. Yep. Good stuff.
So, like I mentioned, there are challenges, especially the first bullet, right? Supporting the latest standards. Like, just to give you an example, Kevin, right? We've had an 800 gig test solution now out in the market for probably north of 2 years. Okay. But that was pre-spec, right? The IEEE, they have an 802.3 DF spec for 800 gig that is just about, become a standard. But the market kind of moved on with the Ethernet Consortium spec 2 years ago. So we've been able to keep up with not just supporting the older specs, but also now the IEEE specs. So it's increasingly important that as these specs evolve, you are testing as the specs evolve. The market's not going to wait anymore for, complete IEEE standardization before they put product out. They're doing a lot of Ethernet Consortium-based specs, so on and so forth. So it's important that you keep testing as you progress towards, the latest standards being available in the market. And that's what we've been able to do through the platforms that we have. Okay. Second bullet I've talked about, the multi-vendor interoperability is critical. It's not very often that you're going to see, one hyperscaler or a provider just have a single vendor. There are going to be multiple vendors in the system, whether it's the switches, whether it's the cables, the transceivers, the optics, everything has to work together. It's not going to be a single vendor play. So being able to test, different optics cables, transceivers, switches, all running in a big system, it's very, very important to make sure that kind of everything works as a whole and you have no challenges when you actually go out to deploy these systems in your production networks. Yep. And last but not least, scale and performance testing, right? I cannot tell you how many times in my 20-year career I have seen, people, a lot of our customers claim that their switches or routers are capable of doing 5 things, but when you really stress them out, all those 5 things don't do well at the same time. 3 of them come to their knees, 2 of them perform. So this need to do full box, full scale, high performance testing to kind of simulate real world scenarios is very, very critical. And you need to do all these things before you go out into an actual production environment and essentially validate and test these things in the lab before you roll out.
Agreed. So for those of us, we've published a number of 400 gig tests. For those of us, or for the viewers who've already done 400 gig work, is there any, obviously besides twice the speed, is there any other significant shift in the whole testing approach when we go to 800 gig?
Absolutely, yes. It's a completely different spec. It's a different FEC engine as well. Like the forward error, the FEC engine is completely different. So at its very core layer, it's very different. Just at its most basic level, Kevin, 400 gig is based on 50 gig lanes, so 56 gig SerDes based lanes. Right. 800 gig is based on 112 gig SerDes based lanes, right? So it's twice the electrical, it's twice the capacity per electrical lane, and that is complex. It comes with its own set of challenges. So the test cases and the scenarios are completely different because your core signaling is different going from 56 to 112. And as you're looking at 1.6, and we're looking at 1.6, that now jumps to 224 gig base SerDes. So, whatever testing you did at 400 gigs, great, but you're going to have to do new testing at 800 gig.
Good, thank you.
No worries. All right. Let's get to talking about AI, AI data centers. I'm sure everybody here on the call has been there isn't probably a day where you're not reading a headline about AI right now. The growth that we're seeing in this market is absolutely unprecedented. This market's growing at a rapid pace. Some indications are that, this core market, the AI data center market, and I'm just talking purely about the back-end AI data center, is expected to grow at a 65% CAGR over the next 5 years. That's tremendous, right? Yes. You're talking about massive deployments of GPUs, servers, fabric connecting all these clusters up. The demand, the scale and capacity of this is unprecedented. And what's really interesting is, by the time a customer, a major hyperscaler decides to put up an AI data center, it takes, I don't know, a couple of years to put a really big data center up. What's happening is these AI models are growing in complexity so quickly that in a deployment cycle of 2 years, you're already not big enough to handle these growing AI models. So we expect these cluster sizes to grow. We expect the AI model complexities to grow. And as a result of that, and I'm talking purely on the Ethernet side here, Kevin, I'm happy to discuss InfiniBand, but the AI data center clusters in the back end are still connected through an Ethernet fabric, right? And that is one of the reasons why we're seeing such a rapid uptick in 800 gig deployments, because, if you look at an AI data center cluster versus a traditional front-end data center cluster, a front-end data center cluster can live with packet loss and latency, right? You'll see a little blip on the wire, yes, no love lost. Yep. But in an AI data center, if you have packet loss, you have latency, all your resources come to a grinding halt and sit there and do nothing. Right. There is I think this was reported by Deloro, where Meta's GPUs are sitting idle 33% of the time because of network congestion. So, the role of Ethernet in the data center fabric is very, very, very important. Okay.
Right. And GPUs are a very expensive resource.
If you can get your hands on them too.
Right. If you can get your hands
right. If you can get your hands on them. Yes, they're incredibly expensive, incredibly power hungry as well. And, I'll kind of talk about where our focus has been over the past year at Spirent. I've talked about a lot of this already in terms of, the complexity and scale of these massive AI data centers. But what is fundamentally different about the workloads generated in an AI cluster is that they're fundamentally very different than the traditional data center. So, taking a traditional test tool like, Spirent or its competitors have built over the past, 15 years, and applying those test capabilities to validate an AI fabric is not the right thing to do. You're not going to using the traditional methodologies that Spirent's put together or anybody else has put together is not the right way to test the AI fabric. It is critical that the testers evolve as well to be able to generate these complex traffic workloads that mimic actual AI traffic running through the Ethernet fabric.
Yep, exactly.
And that is what we really set out to do. And I'll talk about that in the next couple of slides.
Okay.
But yeah, and that's really where the complexity lies. Running a standard RSC 2544 test to test your Ethernet fabric, connecting a bunch of GPU clusters, is going to show you that everything's great. But when you actually go to deploy, you're going to see tons of problems. And I've had customers who basically told me that. So what did we set out to do? So the simplest way I can put this is we have set out through our hardware, and this is on the 400 gig side at the moment, to emulate these GPUs on our hardware to create AI workloads to stress test the Ethernet fabric. So this is not your standard 2544 test. There is a very specific communications collective which takes these massive workloads, breaks them up into smaller chunks. It has very specific transmission patterns based on which it is sent out into the fabric to test how the fabric is performing. And with our unique ability now to emulate these GPUs and the traffic workloads coming out of them, we can truly stress test the fabric, the Ethernet fabric in the AI data center cluster, to make sure that when it's actually deployed, you're getting the best performance out of that fabric. So your GPUs and your entire AI data center infrastructure is working to the best of its ability. It's not sitting there idle. You've validated and tested this in the lab using the Spirent equipment, and you know where your choke points are, where the latency could potentially occur, and then you configure your fabric accordingly to make sure that does not happen in production. And that's where we set ourselves apart.
So is the choke points typically, today, most switches that are out there are, wire speed, low latency. So do you find, or are you projecting that the choke points occur because of the network design of how this leaves and spine are laid out, or what are you finding?
So what we're finding is, I'll give you an example, right? I can't name the customer, but we had a customer who had this GPU. So they were lucky enough as a customer to have access to GPUs. I'll start there, right? They had created this lab where they had real servers with real GPUs, and they were stress testing and performance testing the fabric with the workloads being generated out of those GPUs, okay? And because the very nature of these workloads is different, there's this notion, Kevin, of a communications collective where a big workload is broken up into smaller chunks and then sprayed or packet sprayed over the network in all different kinds of ways. There's this notion of a ring all reduced communication collective and all to all. Mm-hmm. The transmission patterns are very different, okay? And the fabric is not used to seeing those patterns, right? Because you have to realize, right, Ethernet at its core, as ubiquitous as it is and as long as it's been around, wasn't meant to deal with AI traffic. It wasn't. The fact that it even works is sort of miraculous. So this particular customer had X number of GPUs in their lab, ran the tests, they saw the choke points. Okay, they wanted to scale that test bed out, saying, okay, I've tested with 32 GPUs, I want to go to 256. They didn't have access to 256 live GPUs in a pre-production network. So they took a traditional test bed and ran an RFC 2544 test. It showed zero packet loss, very, very low latency, and everything looked fabulous. They went to deploy in production with real 256 GPUs, and they saw choke points everywhere. What those choke points were, it is because of the way the packets were transmitted. It's this notion of every packet gets transmitted pretty much to everybody else, where they saw a lot of priority flow control congestion being created. There was PFC, DCQCN, a lot of reordered packets. In a lot of instances, they saw reordered packets as well, right? Packets coming in out of sequence. So what the specific reason was a combination of things. But the problem there was, Kevin, is they could not recreate that scenario at scale in their labs.
Okay, yeah.
So unfortunately, they had to test in production, and things went south very, very quickly. Okay, and that's when they realized that these traditional tests with RSC 2544 or just continuous traffic tests is not good enough to test their AI fabric. It's fine to test their front end data center fabric, not the AI fabric.
Yep, makes sense.
Very different.
Yep.
So what we really bring to the table, right, is, look, I've been talking to customers for about a year now, okay? And most of these customers are in this gray bar, which is they've had no choice up until now but to go out and build real labs with real servers and GPUs to test the performance of their Ethernet switches. Right, all these NEMs are the NEMs are looking obviously to sell to the hyperscalers. The hyperscalers want to stress test the performance of their fabric because they don't want their GPUs sitting idle. But 9 out of 10 customers I've spoken to actually went out and built these labs. They are incredibly expensive to deploy. Obviously, the cost of the GPUs is just one aspect of that. The operating costs are incredibly high, whether it's power, whether it's skills. Very, very high to manage and maintain. And more than anything else, there's a real lack of skill in people creating actual test methodologies with these real GPUs that is consistent and repeatable so that people can actually, benchmark different switch vendors to see whose fabric is the most lossless and performs the best. Yeah. And that's where we come in, right? What we're looking to do is, okay, look, we'll take the cost, complexity, maintenance, all of that out of your testing, and we will give you a Spirent piece, a Spirent solution, which will really increase your ROI. You buy our equipment, whether it's 16 ports or 256 ports, which can emulate anywhere between 16 to 512 GPUs, and our equipment has a smaller footprint, easier to manage. We have the expertise in test. We will now be able to recreate those AI workloads and tell you how your switch fabric is performing. We've approached multiple NEM customers who are building switches to sell to the hyperscalers who want to test this in their labs. And they've been doing that right now by building real GPU-based labs. Yep. And the hyperscalers as well, who don't know how to benchmark one vendor versus the other. Right? They're having to do this in production right now, which is a real problem for them. So that's where we come in. We have a solution that's ready to market right now. It is 400 gig based at the moment, but we do have plans to take that up to 800 given, that we know that market's coming thick and fast.
Okay. And Aniket, everything you're saying, we've seen in the real world. We've seen, these scenarios that you're describing, we're a testing firm. We've seen them as well, and the same issues, the expense, the complexity, even to get up to 64 GPUs is probably impossible for most companies, and even that
right.
will tell you what happens beyond 64 when you're running the NCCL and other type of of real world types of micro benchmarks and actual traffic. So
Yeah,
absolutely.
and to your point, Kevin, right? NCCL, our collective communications library has NCCL suites in it, right? So we'll run the nickel test. But there's so many of them. There's nickel, there's HICL, there's ACL. But obviously, nickel is the one that we're focused on as well. So yeah, so to your point, we will run those nickel tests, and you'll be able to see how your fabric performs. So what is it that we have, right? We have the Spirent Test Center application that's been around forever, right? And what we've introduced recently is our 400 gig appliances that support, the RDMA over Converged Ethernet or RoCE. We've had that on 100 gig for a while. But what's unique and different now is the emulation of these collective communication libraries, those AI workload traffic patterns on our hardware, right? So we've taken the complexity out of trying to figure out how do I configure my tests, how do I configure my GPUs, how do I configure my servers. We take all that complexity out, give you a really simple, easy to use wizard to set up your RoCE, set up your traffic patterns, and more importantly, it's one thing to generate the traffic, Kevin. We have to report statistics out in a way that makes sense in the AI data center. So yeah, we'll give you packet loss and latency, but we will tell you what your job completion time is. How much time did it take for this entire job to complete? Which queue pairs you were running in your system had the longest tail latency? It will compare the ideal theoretical job completion time to your actual job completion time. And if there are choke points, we'll tell you, okay, this particular set or 50 sets of queue pairs had the longest tail latency, and this is what impacted your job completion time. So we'll give you the insight as well that if things do go wrong and your job completion time or your JCTs are higher than where they need to be, we'll tell you why, right? And this is not a one-trick pony piece of hardware. This hardware has been out for a while. It can run in the standard Spirent personality that does the 2544, the OSPF, the routing test, and then it has an AI personality, right? So you're protecting your investment there as well in buying one piece of hardware that has multiple personalities to run multiple types of tests.
So are there different cards that you use for the AI, or it's a license upgrade, or how does that?
It's a license. It's a license, Kevin. It's a license. Correct.
Good. Okay. Well, good stuff. And everything you're saying, we've seen it. So, everything you're saying in terms of the expertise that's needed, that's not there, just the challenge of, for all of us in the network side, looking at something that's so radically different than we've had for decades, is a huge challenge. And something like this is certainly going to be welcomed by anyone who's trying to deal with that challenge.
Yeah, no, absolutely, Kevin. So it's a great challenge and it's a great opportunity, right, for us, for the Tolly Group as well, because to me this is the new era of being able to do testing right now. I really think we're just at the beginning here. We're at the start. I expect we will all learn a lot as we get our foot in the door in these test beds on how we need to tweak, tune, optimize performance. But so far the feedback's been overwhelmingly positive.
Absolutely.
So I'll go through this quick, but these are kind of the use cases that we cover. We do multiple communication collectives, CCL traffic patterns, all to all. Ring all reduce is the most common, but we'll keep adding to this as we make progress. Right? It's incredible how rapidly this space is evolving. But we can simulate the traffic patterns. We can realistically respond to congestion scenarios, whether it's PFC, DCQCN, and like I've mentioned, right, we will give you not just the packet performance, but the service performance. How much time did it take for the job to complete? You can run negative and impaired traffic tests. We have a network emulator product as well, so you can actually control the impairments if you want as well, to see, under this condition of network impairment, what's going to happen. Under the other condition, how does the fabric respond? So we give you all that capability through a single vendor, which is us.
Is that layered into the network impairment, Aniket? Is that layered in the same box, or how does that work?
No, that's an external box. That's a standalone box that kind of sits in front of this box, if you will. Okay. Takes the traffic in, and then you can impair the traffic coming in as and when you want.
Okay, very good.
Yeah. And like I said, we're up to 400 gig right now, but we are, have active plans to, get up to 800 gig very, very quickly. Rest assured, all our platforms coming out, from the 400 gig and beyond will have this personality available on it, because we know that's where the industry is headed as well. Okay. Last slide, right? I think I have one more. The second to last slide. Most people, unfortunately, right now are on the left. They're doing very basic AI testing if they're using a test tool. If they're using real GPUs, maybe they're doing a little bit more, but it's difficult for them to do if they can set those test beds up. But most customers are doing the basic AI testing right now. They want predictable, repeatable results, which is easy to do, and they're doing basic, network topology testing. Spine leaf, we'll do a 2544 test. We'll do some, boasty traffic patterns, and that's it. That's kind of where they'll end. But where we come in is we obviously do those for, right out of the box. But if there's AI personality, now we can do a lot more. We can simulate these CCL traffic patterns, real congestion control tests, queue pair emulation, things like tail latency, job completion time. So it's, think of, us, the basic AI testing is, for us, it's almost, this is your baseline. Yeah. Do your baseline test, make sure everything works, then really stress test your fabric, create the congestion scenarios, do the CCL traffic patterns that will create congestion scenarios, and then see how your fabric performs, because that's the true test. That's when you go into deployment.
Yeah, when you deploy AI, absolutely.
Exactly, yeah. I had one customer tell me, all this sounds great, but I'll only believe you when your equipment's in my lab and you've actually created congestion on my fabric. And we actually did. So they were pleasantly surprised, because for them it's like, the traditional testers, whether it's Spirent or anybody else, you never created congestion in my fabric. Or once we got the CCL pieces on, once we did the real congestion control, we stressed their fabric out. They actually saw congestion, and they were very, very, very surprised and pleased to see that we were going down this route. So positive. Last slide. Ethernet's here. It's ubiquitous. It's here to stay. We see obviously InfiniBand is going to be very prevalent and continues to be prevalent in the backend data center, but the Ethernet share there will grow, whether it's through rapid deployment of 800 gig, whether it is evolution in the Ethernet space. Obviously there is some amount of innovation happening in the Ethernet space with the Ultra Ethernet Consortium. Spirent's very active there as well. But it is critical that you validate your Ethernet solutions thoroughly, right? You want to be able to run against real world scenarios, test interoperability, and test scale. And more than anything else, if you're someone who is building this huge Ethernet fabric and this huge AI data center cluster with a lot of GPUs, you want to make sure that you're getting the maximum utilization out of that backend AI data center. So, we can provide you with the tools to validate and scale test, but also make sure that you're getting the most bang for your buck through your AI data center cluster by making sure that the network fabric is not your bottleneck anymore. That's causing your resources to sit idle. So that's it for me, Kevin. I appreciate the time, and if there are any questions, I'm happy to take them. Otherwise, thank you.
Yep, sure. No, I asked my questions along the way. I mean, everything that you're saying, we've seen in our real work in testing. The challenges that you talk about, they're all real. Everything you're saying is real. The requirements are real. Your solution sounds like it's something that a lot of people are going to want as soon as they can get it. The growth that you're seeing is what we're seeing. And yeah, while there's InfiniBand there too, there's a lot of people who are Ethernet all the way. And as Ethernet goes 400, 800 beyond, for as long as they can, they want to use that. And if they can make that work for their AI fabric, that's what they're going to want to do. So excellent stuff. Your timing is tremendous with that growth. And good luck with all this. And Aniket, thanks again for joining us today.
Thank you for having me, Kevin. I appreciate the time.